Now, as you have seen that while selecting the stator and rotor slots, harmonics is the important phenomenon in case of motor. So to reduce the harmonics, we are having these two methods to reduce the harmonics. So first one is using cording of windings and second one is skewing of rotor slots. So these two techniques are used to reduce the harmonics. Now first one is using cording of winding. Now what is meant by cording? So cording, the another name for cording is use of integrated slots per pole per phase. So the cording winding means integral number of slots per pole per phase. So remember, cording is nothing but use of integral number of slots per pole per phase. If you use the fractional number of slots per pole per phase, then it weakens the stator winding MMF and which will affect your harmonic torques. So to reduce the harmonics, you must use cording of windings or integral number of slots per pole per phase. Integral means your number should be integer like 1, 2, 3 likewise. So your slot per pole per phase should always be an integer. It should not be a fraction to reduce the harmonics. Now next, second technique to reduce the harmonic is skewing of your rotor slots. So this is your rotor. As you know, in squirrel cage type of induction motor, your rotor slots or rotor bars are skewed. Skewed means what? They are not parallel with the stator slots. They are skewed at some angle. Here this angle is QSK. Here we are mentioning that angle as a QSK, that is skewing angle. So why we are providing this angle to the rotor slots? Just to reduce the harmonics. First of all, or first or most important criteria, we are using such type of skewed rotor for reducing the number of harmonics. After that, to reduce the noise also, again to reduce the vibrations, to reduce the cogging. If your stator and rotor slots are parallel, again your motor, or you will observe the phenomenon of cogging in case of your induction motor. So to reduce this cogging, we are using skewed rotor. So skewed rotor we are generally using to reduce the harmonics as well as to reduce the noise, to reduce the vibrations, to reduce the cogging. Now how to select this angle QSK? So to select that angle or to calculate that angle, we are having this simple formula QSK equal to 720 degree divided by n times P. Now what is this n? So it is in mechanical degrees. N is nothing but your number of harmonics and P is your number of poles. And to convert it into electrical degrees, so QSK equal to 360 divided by N. N is nothing but your number of harmonics. That is third harmonic, fifth harmonic or seventh harmonic, etc. So this is all about selection of the rotor slots. After that, why we are preferring the skewed rotor and all. Now next one is selection of length of air gap. As you all know, there is a air gap between stator and rotor, and there are some factors affecting the length of air gap, which is first one is power factor, second one is overloading capacity, third one is pulsation loss and noise, fourth one is unbalanced magnetic pull, that is UMP. Now how power factor affects the length of air gap? Now remember, if you want good power factor, you must select the air gap as low as possible. But if you want good overload capacity or less pulsation loss and noise as well as less unbalanced magnetic pull, then you must prefer large air gap. So for good power factor, your air gap length should be small as mechanically possible. But for large overload capacity, less noise, less pulsation loss, less UMP, the length of air gap should be large. So depend on your requirement, you have to select the air gap. As if you want good power factor, then you must go for the less or small air gap. And if you want good overload capacity, less noise, less unbalanced magnetic